squeeze theorem is to prove or show that, I'm just going to write it here on the bottom. So the limit is x approaches infinity of sin e to, I think it's ex, like that, over x squared. Let me just double check. Okay, and that's equal to 0. So we're supposed to prove that this is equal to 0. What you want to do is obviously squeeze in your trig ratios. So in this case, we're squeezing in sine, and because we don't have a squared here, we would basically be going from -1 to 1, right? So you would have -1, then you have sine x and 1, right? And now because we have e to the x, so the idea here is to basically make the middle look exactly like what the given function is, right? So we have to make this look like everything here, so everything there. First part would obviously be changing the angle. So we have e to the x smaller than or equal to 1. And whenever you're changing the angle does not really change your values on your right and left. It basically, I don't know how to explain it, but anytime you're given an angle, you don't have to change anything here, or your inequalities, you don't have to change, right? And then now we're dividing by the x squared. So now the next step would be -1 over x squared sine e to the x over x squared, and the 1 over x squared, right? And now because our middle looks exactly like what we have here, then we can now apply the squeeze theorem. So we're basically going to find the limit of this here on the left, and then find the limit of the right. And obviously, if they are both equal to 0, by default, this would also be equal to 0, because if you think about it, this equal to sign here also tells us that the limits would always be equal to one another. So lim as x approaches infinity of 1 over x squared, this is the same as the limit as x approaches infinity. And then because we obviously are signing infinities, I'm going to divide by the highest degree on my denominator. So I'll have 1 over the x squared all over, so x squared over the x squared. Don't know, do I have space here? Okay, so this would be the lim as x approaches infinity. You would have 0 over 1, and that is basically 0, right? Okay, so it was supposed to be negative here, so I was supposed to use the negatives because I was dealing with this side. Now I'm going to do for this side, and I hope you can see that we're basically going to do the same thing, and we're going to end up with a 0. And by default, the limit as x approaches infinity of sine e to the x over x squared would also be equal to 0. So just gonna write and the lim as x approaches infinity, and we have 1 over x. Actually, I just want to move this a little bit to the left. So this is the same as the limit as x approaches infinity of 1 over the x squared and the x squared over x squared. And I hope you can see that we would have the limit as x approaches infinity of 0 over 1, which this is basically 0, right? And by default, or you can say therefore, by squeeze theorem, the lim as x approaches infinity of sine e to the x over x squared is also equal to 0. And that right there is your proof, and you would basically get your 3 marks. I think it's 5 marks. You would get your 5 marks, right? And then they're saying to us, hence evaluate this. So we have to find also the squeeze theorem of that. I don't know where. Obviously, it has to give us a 0. I think it does have to give us a 0, but we would see. Let's see. I think I'm just going to move all of this. I don't know where. I'm not going to move it. I'm just going to remove it. Just make sure you have your answers saved. Okay, so hence evaluate. Let's do B here. So we have the limit as x approaches infinity to x cubed plus sine e to the, plus sine x squared over 1 plus x. I think that's cubed. And also, I think I might have made a mistake with saying the answer might be 0, because if you think about it, this function is not really the same as that function. I think the hence, they want us to use squeeze theorem, and not specifically that the answer would be a 0, right? So we just have to use squeeze theorem, and we're just going to prove it here. So we would have negative. So yeah, I also want to highlight that you be careful with your angles. This squared is not here, so you wouldn't use the 0 up to 1. You basically want to use negative 1 to 1. So you would have sine x 1, and the next step would be negative 1 sine x squared negative 1. Like I said, the angle really does not change anything. And now we're adding this, so we're going to add it everywhere so that we can have it in the middle. For us to have it in the middle, we have to add it everywhere, because remember, this formula says all of these, so basically whatever that happens here is less than but can be equal to, so we always have to make it equal to, because it can also be equal to, right? So the safest would make it equal to, so whatever we want to do here, we have to do everywhere. So we're adding 2x cubed, so 2 x cubed minus 1 and 2x cubed plus sine x squared and 2x cubed plus 1, right? And then we are dividing by a positive denominator, so that means we basically don't change our inequalities, they remain as they are. So that's 1 plus x cubed. I'm just going to do it here, 1 plus x cubed. I'm doing it here because my inequalities are not changing, so you wouldn't change anything. 1 plus x cubed everywhere, 1 plus x cubed. And now, because our middle looks exactly like the given question, we can now apply the squeeze theorem using the limits. Therefore, the lim as x approaches infinity of 2x cubed minus 1 all over 1 plus the x cubed, that's equal to, so applying what you would with if you have obviously infinity signs, you'd want to divide everything by the highest degree of the denominator, and in this case we're using the x cubed. So you would now have the lim as x approaches infinity 2x cubed all over x cubed, sorry, that's minus 1 over x cubed all over, I think we had 1 over x cubed plus the x cubed over x cubed, right? And this, if you check here, this would give you 2, that's 0, 0, and 1, and your answer is basically 2 over 1, which you can just write as 2. So your answer for this is 2. Now let's go ahead and find the limit for the other side. Obviously, by default, you can see that here you would have a 0, a 0, a 2, and a 1, and the limit this side should also give you a 2, and by default, the limit here is 2, right? So you would have your and the lim as x approaches infinity of 2x cubed plus 1 over 1 plus the x cubed, that's equal to the lim as x approaches infinity of 2x cubed over x cubed plus 1 over the x cubed over 1 over x cubed plus x cubed over x cubed, right? Looking at this, this would give you 0, 0, a 2, a 1. So you would now have 2 over 1, which is the same as 2, and that's your answer. And because we have two answers that are the same on the left and on the right, by default, the lim as x approaches infinity of 2x cubed plus our sine x squared all over 1 plus x cubed is also equal to 2, right? So that's by default, obviously. So this is how you would answer this question with 3 marks. Moving on to the next question, where we're supposed to use squeeze theorem to determine the limit of h approaching 0. Let me just write it down because I can't see what's going on by looking at that. So you would have the lim as h approaches 0. Your function is h times sine 1 over h. Oh, so we have to find the squeeze theorem of this. So because we just have sine as the original function, we're going to go from negative 1. Then you have your sine x. So let's use h instead. And you have 1, right? So this is equal to negative 1. And then you have the sine, or the sin, 1 over h. And your 1 there. And then I think we're supposed to multiply by h. Because we're multiplying by a positive h, that would mean our inequalities don't change. Inequalities, I mean those do not change direction. So you would have negative h sine 1 over h greater than or equal to h. And because our middle looks exactly like the given function, that would mean we can now start with the squeeze theorem. So the lim as h approaches 0 of negative h is the same as negative 0, which gives us a 0. And then evaluating the right would be lim, so we're just going to write your and here, as h approaches 0 of the positive h, this is 0, which is 0. So I don't think I have to write that twice, but just for the sake of writing it. And because now the limit from the left and the right coming obviously to the same value, by default, the limit in the middle is also equal to 0. So lim as h approaches 0 of h times sine 1 over h, that's also equal to 0 by default, obviously. And that's how you would answer the 30-mark question given to you. Okay, question 1.2a says we have to find the squeeze theorem to show or to prove that this is equal to 0, and we're going to do that for 5 marks. So we have lim as x approaches infinity, and I'm just writing these for the people who won't be able to see clearly. I think that's e to the x over x sine e to the x over x is equal to 0, and yeah, let's just prove that. Using squeeze theorem, you would have negative 1 sine x and 1, right? Negative 1 sine or sin e to the x. Remember, the angle does not change anything. And then because we're dividing by a positive term or variable, you don't have to really have a next step because your inequalities would not change. And then now evaluating our limits, we would have the lim as x approaches infinity. I think we had negative 1 over x. So that's because we're dealing with infinity, you'd have to divide by the highest degree on the denominator. So you'd have negative 1 over x all over x over x. This would give us a 0 over 1, and that's 0, right? And the limit as x approaches infinity of positive 1 over x is the same as 1 over x. Oh, sorry, I think I did something incorrectly here. Okay, so I was supposed to have a limit as x approaches infinity, right? Which is kind of what I almost forgot here. Remember to always write your limits if you want all your marks, obviously for all the time you spent on the paper. So the lim as x approaches infinity of 1 over x over x over x, this would be the same as 0 over 1, and that's 0. And because we have the same value, or our limits going to the same y value, that would mean by default, or by squeeze theorem, the limit as x approaches infinity of sine, think it as e to the x over x is equal to 0, and that's your proof. If you were asked to justify your answer, you would basically justify by saying this limit, or the limit from the left, is equal to the limit from the right. Let's do B, where we're supposed to, okay, they kind of found or done half the squeeze theorem for us. If you look at it, you have a function, so you have this function squeezed in this right function and this other function. So you have 3 things going on, and they're telling us the limit that we have to, or what value of x is being approached. So for this, it's quite simple. Although it looks hard, it's I think it's also 3 marks because they've done half the work for us, right? So we just have to find the limit of this. We don't have to find what f of x is. We just have to find its limit. And obviously, if we can be able to prove, if we are able to find the limit for these two, then by default, we found the limit of this, and that would be the answer. So I'm just going to write them down. So you have 1, you have f of x, and that's x squared plus 6x plus 6, right? So if we can evaluate the limit for this and all of that, then we by default have found the limit for this. So they're telling us to use x approaching -1, so that's what I'm going to use. x approaching negative 1, 1, and that's 1. Let me just move this to the bottom to make my work a bit neat. Right? So, and the limit is x approaches negative 1 of the x squared plus 6x plus 6. If obviously we substitute in the 1, let me do it here. So you'd have negative 1 squared plus 6 times the negative 1 plus 6. This is 1 minus 6 plus 6. So minus 6 plus 6 is the same as 1. So you would basically just have, minus 6 plus 6 is the same as 0. So you basically just have 1. And because the limit on the right is equal to the limit on the left, by default, lim as x approaches negative 1 for f of x is also equal to 1. And that's basically our answer for 3 marks. They would obviously mark this and that and that. So make sure you show all your steps and everything that's required from you. Okay, let's do this question worth 5 marks. I've already wrote down the question just to save time and space, right, for my phone, and not to make the video longer than it's supposed to be. So finding using squeeze theorem, I'm firstly going to start with the sign or the sin, and then after that multiply with this everywhere. So you'd have negative 1 sin x and 1, and because now our angle is 1 over x plus 1, I'm just going to change the angle to that. Right? Remember, the angle really does not change what your inequalities look like. And then it says now we should multiply by x plus 1 squared. I'm just going to do that everywhere. So now I'd have x plus 1 squared, x plus 1 squared, multiplied now by the sin 1 over x plus 1. And this side also changes to x plus 1 squared. Right? And now because our middle looks exactly like the given question, I can now just apply the squeeze theorem. Can I just check what the limit was? X approaches negative 1. So the lim as x approaches negative 1 of negative x plus 1 squared is that, negative 1. So that's 0 squared, which is 0. And then doing the other one, so I'm just going to write n here. The lim as x approaches negative 1 of x plus 1 squared, negative 1 plus 1 squared, that would be 0 squared, and that's basically 0. And so by default, our middle, or this basically, is going to be 0 because we have two limits that are equal. So by default, the middle has to also be that. So now you would have the lim as x approaches negative 1, x plus 1 squared, multiplied by the sign or the sin 1 over x plus 1 is equal to 0 by default. And that's how you would answer your 5 mark squeeze theorem question. Okay, let's do C. They say using squeeze theorem, determine, I'm just going to write it here. So lim as x approaches infinity, and I think we're dealing with cosine. So you have 2 minus cosine x cubed all over 2 plus x squared. So just make sure that you also enclose your angles to not mistake them with, I don't know what else you could do, but just make sure you enclose them, right? So finding the squeeze theorem of that, you would have negative 1. So let me actually write this down here. Negative 1, and then you have your cosine, so x cubed and 1, right? And then we have a negative, or we basically have to multiply it with a negative. So now our inequalities are going to change. Negative 1 times a negative is 1. Inequality changes, and you have a negative cosine x cubed and a negative 1 this side. And then we're adding a 2 everywhere. So 2 plus 1, that's 3. So 2 minus cosine x cubed. And then you do your -1 plus 2, that is 1. And think of it, this actually does make sense, because all of this, remember, where everything is, or where actually initially where this was bigger than something, that something had to be smaller, right? So comparing these two, this has to be bigger than a smaller thing. And coming back here, this is now still bigger than a smaller thing, but is smaller than a bigger thing. If you kind of understand what I mean, you kind of didn't change anything, but you did. So that's what you're doing, right? And then now we're dividing by a positive denominator, so I don't think I really have to write in another step. So that's 2 plus x squared everywhere. 2 plus the x squared, 2 plus x squared. And now because my middle looks exactly like my given question, that would mean I can now start with my squeeze theorem. This would be the same as lim as x approaches infinity. And I think we have here 3 over 2 plus x squared. That's the same as the lim as x approaches infinity. And because our highest degree on the denominator is x squared, everything would be divided by that. So you'd have 3 over x squared, all over 2 over x squared plus x squared over x squared. This would give us a 0, and a 1. So eventually you would have 0 over 0 plus 1. And this is 0 because 0 plus 1 is the same as 0. So you can write it like that. And then evaluating the other side, that's a 1 there. Hope you can see what's actually going to happen. Oh, that's x squared actually. This is equal to the lim as x approaches infinity, 1 over x squared over 2 over x squared plus the x squared over x squared. This is 0, and that's a 1. So you really just have 0 over 1, which is 0. And by default, your middle would also be a 0. Therefore, the lim as x approaches infinity of 2 minus cosine x cubed over 2 plus x squared is also equal to 0. And that's really because we have the same limits, right? And this is how you would answer this 5-mark question. And I think you would have answers for, you would have marks for everything here. Okay, let's do this limit with, I think it's 5 marks, and yeah, I just wrote it down to make it easier. So using squeeze theorem, I think we're supposed to use squeeze theorem, not as a limit. So because we have only sine as a, so this would be -1 sine x and a 1, and we divide, we're multiplying it by a negative, so you would have 1 here, these change, and you would have sine x and a negative. This does make sense, right? If you're flipping, so for example, if you had sine, right, like this, and obviously it goes from -1 to 1, this would be sine being squeezed in, but also equal to -1 and 1, right? If you were to flip that, you now would have so if you were to flip that, you would now, oh, that's not really accurate. Yeah, I tried. So if you were to flip that, you would now have something like this, right? So that's now a negative sign that goes from still -1 to 1, but now flipped, so our inequalities would also flip. I don't know if it makes sense, but that's basically why our inequalities are kind of flipping, and that's because our functions going in reverse. Adding 3x to this would be now 3x plus 1 3x minus sine x, 3x minus 1. And because we're dividing by a positive denominator, I don't think I really want to write down another step. 4x plus 5. Okay, from here, because now our middle, which is this part, looks exactly like our given function or the given question, we can now find the limits of these two. So the lim as x approaches infinity of 3x plus 1 all over 4x plus 5. This basically would be the same as the limit as x approaches infinity, and our highest degree on the denominator is the x to the power 1, so we divide everything by that. 3x over x plus 1 over x, 4x over x plus 5 over x. If you think of it, this would give you 3, a 0, 4, and a 0. So you literally just have 3 over 4, right, as your answer. And let's now find the limit on the other side. This would be the same as the limit as x approaches infinity. Highest degree is still x, 3x over x minus 1 over x, 4x over x plus 5 over x. If you think of it again, this is 3, this is 0, that's 4, and that's 0. So this is equal to 3 over 4. And it's really just because if you were to plug in this infinity here, try plugging in maybe, I don't know, negative 100,000 billion on the denominator and see what really that approaches. Kind of approaches 0, because you would have 0, 0, 0, 0, 0, 0 up to 1. So you basically have something like 0, 0. And because 0 is being repeated, you'd have that recurring decimal of 0 until 1. So that's really approximately a 0. And that's why your answer is this. So by default, because the left limit is also equal to the right limit, that would mean the limit for the middle is also equal to 3 over 4. So the limit as x approaches infinity of 3x minus sine x all over 4x plus 5 is also equal to 3 over 4. And that's how you would answer this 5-mark question. You don't have to draw this. I was just explaining, but that's how you would answer this question. Moving on to the next question, which is quite similar to what we did. We have to determine the limit of, or as k, actually, k approaches infinity. We have to determine the limit of 5k squared minus cosine 3k over k squared plus 10. And yeah, let's really just start. So you would have negative 1 greater than or equal to cosine x smaller than or equal to 1. Multiplying that by a negative, you would have 1. Inequality signs change. And I'm just also going to add in the angle. Adding 5k squared plus 1, 5k squared minus cosine 3k, 5k squared minus 1. And because our denominator is positive, I don't think I really want to change or write the next step. Okay, now the middle part looks like the question that was given to us or posed to us. So we can then now find the squeeze theorem, or squeeze the limits to find the limit for this. So the lim as k approaches infinity of 5k squared plus 1 over k squared plus 10. Because we're dealing with the infinity value, we're going to divide everything by the highest degree of k, which is k squared. So 5k squared over k squared plus 1 over k squared over k squared plus 10 over k squared. And we're also really just dividing using the highest degree on the denominator, because we don't want our denominator to be 0. If you think about it, for example, if you had, let's say on your numerator, you had k cubed, and on your denominator you had a k. If we were using the highest degree on the numerator, we would have k3 over k3 over k3 over k, which basically doesn't really help our case, right? Don't know if it makes enough sense, but we look at the denominator. Okay, so for this would give you 5, 0, 1, and 0. I think that was supposed to be 10 here. So you basically have 5 over 1, which is 5. And for the limb, as k approaches infinity, of 5k squared minus 1, I think it's supposed to be minus, yep, over k squared plus 10. That is the same as the limb, as k approaches infinity. Highest degree on the denominator is k squared. And this really is 5 minus 0 over 1 plus 0. And that is 5 over 1, which is equal to 5. And so by default, the limit as k approaches infinity of the given, which was 5k squared minus cosine 3k over k squared plus 10 is also equal to 5, right? And I hope it does make sense. And that's really because we have two limits that are equal, and by default, the third one would also be equal to the 2. Next question says we, for 3 marks, we're supposed to use Squeeze theorem to prove this, and then hence evaluate this. So after finding this, based on that answer, we have to find this. And I would think we would get the same thing. Right, so we have the limb as x approaches infinity of sin, I think it's e to the x over x being equal to 0. So obviously it starts with the -1 sin x 1, right? And then we change our angle. Remember, the angle does not change your inequality signs or your values before and after the inequality signs. Dividing by a positive denominator wouldn't change anything as well. And now our middle part looks exactly like the given question. So you just have to find the limit here and the limit there. And if they're equal, that would also mean the limit of this. So the limb as x approaches infinity of -1 over x. Because we're dealing with infinity, you would divide everything by the highest degree in the denominator. In this case, you would have the limb as x approaches infinity, -1 over x over x over x. The numerator would give you 0, the denominator would give you 1, so you would have 0 over 1, and that's really just 0. So and the limb as x approaches infinity of 1 over x is the same as the limb as x approaches infinity 1 over x over x over x. That's really just 0 over 1, which is 0. Right? And because these two are equal, that would mean by Squeeze theorem, the limit as x approaches infinity of sin e to the x all over x is equal to 0. And by that, you've proven the 3-mark question. And now hence we have to evaluate this. So with evaluating that, you can really just start from this point and just add in your given denominator. So this denominator, and then you can work on it like you would with if you have a limit approaching infinity, and that would be your answer. Because it's going to be quite long, I'm just going to remove everything that I found for the first question. And work on the second question. So you have the limit as x approaches infinity sine e to the x over, I think you had x squared plus 2. Okay, right. So from this, obviously your squeeze theorem would be -1 greater than or equal to sine e to the x. You don't really have to start from the beginning because they expect you to know how it has to look from this, because it's a hence. You use the previous answer to prove this, right? So you would then also have a 1 here, and our denominator is not changing signs. So you have x squared plus 2, x squared plus 2, x squared plus 2. Right, and so from this, we can then now find the limit this side and the limit that side. So the lim as x approaches infinity of negative 1 over x squared plus 2 is the same as the lim as x approaches infinity of negative 1 over, so you take out a common factor of x squared, you'd have 1 plus 2 over x, which that is equal to the lim as x approaches negative infinity, negative 1 over, taking it out, you'd have x squared, 1. And then remember, I'm just going to do it here on the side. X squared is the same as this, basically. So you can just now just change it to that. So this would be equal to the lim as x approaches negative, oh, was I supposed to be infinity? Infinity, negative 1 over x. And then remember, square root of 1 is the same as 1. So you can just not write it. And then remembering the thing is about absolute values, because this is coming from the positive. I mean, it's not a side. So you assume that this is also positive. So you would have now the lim as x approaches positive infinity of negative 1 over x. And you basically do the same thing that you've been doing. So you would have negative 1 over x over x over x. And that's 0 over 1, which is equal to 0. So I'm just going to, let me write it in red. This is equal to 0. And then you basically now have to do the same thing for the other one. But I'm just going to copy everything and just remove the negative signs because it's the same thing, just that the other one is negative. So I'm just going to add in the and. So by default, the limit as x approaches infinity of sine e to the x over, so x squared plus 2 is also equal to 0. And that's really because we got a 0 here and a 0 there, and by default you would have a 0. And for 3 marks, I think you would be expected to do all of this. Now they say using the squeeze theorem, we have to determine all of this, and then they give us restrictions that x obviously cannot be equal to 0 and also cannot be greater than 0, because if you think about it, if x is equal to 0 here, this would basically mean we have an undefined angle or an asymptote, and that is actually not possible for an angle to be that, so hence why we have restrictions. So let's now find the squeeze theorem. So you'd have negative 1 greater than or equal to, sorry, smaller than or equal to cosine 10 over x, smaller than or equal to 1, right? Okay, yeah, so that's the angle. And multiplying the x cubed, you'd have x negative x cubed, smaller than or equal to x cubed, and the cosine of 10 over x and x cubed. And because our middle part looks like our given question, we can then find the limits for this and that. So the lim as x approaches 0 of negative x cubed would be equal to negative 0 cubed, which this is 0, right? And the limit as x approaches 0 of x cubed would be 0 cubed, which that is 0. And so by default, the limit as x approaches 0 of x cubed multiplied by cosine 10 over x is equal to 0 as well. And that's how you would answer that 3 marks question. They say we're supposed to use the sandwich theorem to determine the following. Remember, another way to say squeeze theorem is defining it as the sandwich theorem. So that's the lim as k approaches 0, k cubed times sin 1 over cosine k. So I'm just going to do it here. So negative 1 sine x 1, right? Now remember, our angle does not change anything. So sine 1 over cosine k wouldn't change anything. And then multiplying everything by the k cubed, you'd have negative k cubed sine 1 over cosine k and the k cubed. So this is equal to the limit as k approaches 0 of negative k cubed. This gives you negative 0 cubed, which is 0. And the limit as k approaches 0 of k cubed is equal to 0 cubed, which is 0. And so by default, because we have the same limits, that would mean the limit as k approaches 0 of k cubed times sin 1 over cosine k is also equal to 0. And that's how you answer that kind of squeeze theorem. D says use squeeze theorem to determine the following limit. So we're given lim as k approaches 0, k cubed, and we have cosine 20 pi x. Let's say 20 pi k, not x. Okay, remember to not treat pi as a variable. Pi is a constant. So just remember that. But it wouldn't matter in this case. So you have negative 1. Then you have your cosine k 1. This is the same as cosine 20 pi k. Remember, angle does not change anything. We're multiplying it to k cubed. That's negative k cubed cosine 20 pi k and the k cubed. Right? Finding the limits on both sides. So the limit as k approaches 0 of negative k cubed. That's the same as negative 0 cubed, which is 0. And the limit as k approaches 0 of k cubed, and that's actually 0 cubed, which is equal to 0. And so by default, the limit as k approaches 0 of k cubed times cosine 20 pi, was it k? That's also 0. And that's because our limits are going to the same y value. And so this is how you would answer that question. I don't know how much or how many marks it's worth. Please do this question on the comment section and send in your answers in the description, the comment section. So using squeeze theorem, determine the following limit. So we have lim as k approaches negative infinity, 5k cubed plus sine 3k over 10 minus k squared. Right? So this would be negative 1 sin k and 1. Dealing with 3k, so our angle would change to sine 3k, like that. And we're adding 5k cubed, so 5k cubed minus 1, 5k cubed plus sin 3k, and 5k cubed plus 1. Our angle is 10 minus k squared, so I'm just going to write it here. 10 minus k squared, 10 minus k squared. And now because this middle part looks exactly like what we have here on the question, I think we can now just do the limits. So the limit as k approaches negative infinity of 5k cubed, so minus 1 over 10 minus k squared. Let me just double check. Yep. So because we're dealing with the infinities, you would want to divide by the highest degree on the denominator. And that would be lim as k approaches negative infinity, 5k cubed all over k squared minus 1 over k squared all over 10 over k squared minus k squared over k squared. This would give you the lim as k approaches negative infinity. You would have 5k over 1, or negative 1 rather, which this solves to, let me see, because we no longer have a degree or a variable on our denominator, we can just substitute in the negative infinity. So you would have 5 multiplied by negative infinity over negative 1. Let me actually move this. I think it's fine here. So if you think of it, this would be negative infinity over negative 1. The negatives cancel, and you would have an infinity there, right? You would have an infinity there, and doing the same thing, but in this case with the plus 1. So I'm just going to add in the and here. So doing the same thing. So if we had a plus 1, you would have that. Subbing in the negative infinity, you would still have the same answer of just infinity. Wait. So I didn't do something right here. I was supposed to actually just copy. So let's move this back up a little here, right? And do one with a negative. So I'm just going to copy in the same thing, and then we're going to use negative. So and then instead of a positive sign, we would be using 1 now with a negative. Okay, so basically what I just did, so for this limit that we were finding here is for this, and then this one is for that one, right? And because we have the same limit, y value that we're approaching, that would mean by default the limit of this is also infinity. I don't have enough space, as you can see, to work on that one, but that's how you would work on this kind of answer. Please try this on the comment section. So on the comment section, you actually have to give me 2 answers.